4.3 video talks about the Euler number, and it is a very long decimal number, kind of like pi is. And in our calculator, we have a symbol that we use for Euler number, and it's just E. And if you're interested, that E stands for this long decimal number. And it keeps going on and on, kind of like pi. So in your calculator, I'm going to show you where E is. And it is the second key. Oops, let me turn on. The second division sign will give you that number. And if you push enter, of course, you'll get the same number that I got on the board. All right, next we're going to simplify expressions with these Euler numbers. And so here is the first example. When we do this, we treat it just like a variable. So we're going to have 3 plus 4, which is 7. The second example, we have something like this. We do have to put the 3 onto everything. So the 2 gets a 3. And then this gets a 3. And remember, when you have an exponent already, you just multiply them together. So this will get simplified to 8e to the 9x. The next example, we have a division problem. Same thing, we're going to take the whole numbers, so 3 divided by 1 is just 3. And really we have a 1 here. We're going to subtract the exponents because we have the same base. So keep your base, subtract 1 minus x. Because we can't actually do that, we'll write it out just like that and leave our answer that way. And the fourth problem, just like we took number 2 and we cubed all this, we're taking the cube root of this answer. So we should come up with this in parentheses if we do it right. So we know the cube root of 8 is 2. And the cube root of an exponent, remember we take the 9 and divide it by 3, which will become 3x. Okay? Now we have some problems in our book that will ask you to use a calculator to evaluate the expression. And that just means that we're not going to simplify it. We're actually going to punch it into our calculator and get a decimal. And because we're going to round those decimals, because we're not going to sit here and write out all of the decimal numbers, we're going to put a little squiggly line instead of the equals, and that just means about. So we have to go to our calculator, and because this is e to the third power, we're going to do a second, the division sign, raised to the third power. And there's our answer. So we can write 20.086 if you really wanted to. That's why we put those squiggly lines to let everybody know that we are rounding. All right, number 2. Okay, we're going to put this in our calculator. So we have the e raised to 2.2. And there it is. So about 9.025. And the last one, same thing, we're going to plug it into our calculator. Negative 6 e raised to 2.4. And there's the answer. Now we need to tell whether the function is exponential growth or decay just by looking at it. And this is very easy. If your exponent on the e is negative, this is going to be decay. So not only should you write decay here, but you should write a note to yourself about the exponent being negative, meaning decay, and if it's positive, meaning growth. So if we look at the next problem, is this decay or growth? This exponent here is positive, so it's going to be a growth. Now we're going to graph the function and state the domain and range, and we have done this before. Here is our first equation. Remember, we can sketch it for our homework. So we're going to go to our calculator. We're going to go to the y equals. And we're going to punch in 3e raised to x. Okay, so there's our graph. And so we will sketch that. And we just have to write the domain and range. The domain is talking about the x values, and the graph goes in the negative direction and the positive direction, so all real numbers for x. And the range, it looks like the graph is above this 0 here. So y is above, meaning more than, 0. And remember, we have to check our chart to see if it actually hits. That's going to tell us whether or not to put this line here. So we go to the chart here, and we scroll up around the 0 area. You can tell that your graph gets smaller and smaller, but never hits 0. So that just means we will not include the line underneath of it, because it never touches it. Okay, here's the next example. Again, we're going to go graph it. So it was 2e raised to. Now if there's more than just one thing in the exponent, make sure you use parentheses and close it. Okay, so that negative 3x is in parentheses. That means that that is part of the exponent and the minus 1 is not. You go to your graph. We're going to sketch it. And we do domain and range. Domain, it is going in the positive and negative side of the x, so all real numbers again. In the range, looks like the graph stays above a number down here. We have to figure out what that number is. So we're going to go to our chart. And maybe go the other way until we find it. And as you can tell, it stays above -1 because all of these numbers here are all -1, so it touches it. So we're going to say above it, meaning above, more than, and equal to -1. The last part of this section talks about continuously compounded interest. And we've already done some compounded interest. Sometimes the interest gets added daily or just, quarterly or even one time a year. Continuously means it's ongoing every minute of the day. And that equation has to do with the Euler number. So we still have our P, which is our principal or starting amount. The Euler number is involved, and that is going to be raised to the rate times the years, which is T. So here's an example. You deposit $2,000 into an account that pays 4% interest compounded continuously. What is the balance after 5 years? Some key things we need to point out are the $2,000, which is our starting amount. And the rate is going to be 4%, but remember we change it to a decimal. And then the continuously is a key word that you're going to need to recognize on your test because it's going to tell you to use this equation, not the other two that we've went over. So continuously means that we'll put this E in here, and then the time, which is 5. Now when we plug this into a calculator, we want to make sure we do it right. So we're going to plug in 2,000 E, but the raised to part needs to be in parentheses. So 0.04 times 5. All needs to be in parentheses. And when we push enter, we get this number. So $2,442.81. So we're getting an extra $442.81 just by leaving our money in for 5 years that gets interest continuously. It's a lot of free money.